Good morning, all of you. I am going to handle a video lecture regarding the subject Engineering Mechanics. The subject code is G8292. This is the lecture 2 based on the topic Resolution of Forces. Myself, K. RAJASUTHAN, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering Technology, Kanyakumari. Let's go to the slides. Now I will read out the problem first. Four forces 7 kilonewton, 10 kilonewton, 10 kilonewton and 3 kilonewton respectively act on one of the angular point of a regular pentagon towards the other 4 points taken in order. Find out the resultant completely. So what does that completely word means? Find out the resultant in magnitude and direction. Okay. So initially there are 4 forces given, that is 7 kilonewton, 10 kilonewton, 10 kilonewton and 3 kilonewton. These are the 4 forces acting from one of the corners of a pentagon, that is regular pentagon, towards the other 4 corners. Here, how can you draw the diagram means, see the diagram figure 1. So in that you can easily see that from point O, 4 lines are drawn to the rest of 4 corners, okay, and it is taken in order. So 7 kilonewton force acts as the first one, which is perfectly horizontal, acting from OA, okay. Then second force 10 kilonewton is acting towards OB, okay, and the third force is acting towards OC 10 kilonewton, and the fourth force, the final force is acting towards OD, that is 3 kilonewtons, okay. So actually from the figure you can easily note it down that the first 3 forces, that is 7 kilonewton, 10 kilonewton and 10 kilonewton acts in the first quadrant because the angle is less than 90, okay, and the fourth force, that is 3 kilonewton force alone, it is exceeding angle 90, so it goes to the second quadrant, okay. So now we want to calculate the angle of the 3 forces. 7 kilonewton is perfectly horizontal, so it is angle 0, so no problem. But for 10, 10 and 3 kilonewton force, you want to find out the angle, okay. So you know that interior angle for a pentagon. So actually there is a general formula for calculating the interior angle for a regular polygons, okay. You have the formula that is equal to the 180 minus 360 divided by number of sides. Here the number of sides is 5, so that is equal to 180 minus 360 by 5 is equal to 108. Actually generally it's not a problem for you because you know the general interior angle for a pentagon, regular pentagon, as 108, okay. Here that 108 is divided into 3 equal halves, you can see that, okay, 3 Newton force, 10 kilonewton force and the 10 kilonewton force, and again the 7 kilonewton force, it is divided equally into 3 segments, so that 108 by 3 will give 36, so each segment carries 36 degrees, okay. So the 10 kilonewton force, the second force which is acting in OB is 36 degree inclined to the x-axis, and the force which is acting, third force which is acting towards OC, 10 kilonewton force, that is acting 72 degree from the x-axis in the first quadrant, and the fourth force is acting 72 degrees in the second quadrant from the left hand side, okay. So now with this we can draw easily the free body diagram as mentioned in the figure 2, okay. Now we can resolve the forces horizontally. Sigma h, that is sigma s fx, is equal to 7 kilonewton, that is it is exactly horizontal, so plus 7 kilonewtons plus 10 cos 36 plus 10 cos 72, that is in the first quadrant, third force, and the fourth force is nothing but 3 kilonewton force which is in the second quadrant, minus 10 cos 72. So resolving these things we get the answer as SFX is equal to 17.25 kilonewtons. Hence, we obtain the value of summation of horizontal components, that is Sfx is equal to 17.25 kilonewtons. Okay. Now we resolve the forces vertically we get. So actually the first force is purely horizontal, so it can be neglected from the vertical components. Okay. The second force 10 kilonewton is having 36 degree inclined, so 10 sin 36. The third force is also having same magnitude, 10 sin 72, and the fourth one is in the second quadrant plus 3 sin 72. So solving these things we get the vertical component summation, that is Sfy, that is sigma v is equal to 18.24 kilonewtons. Okay. So both the horizontal components and vertical components are positive here, so automatically you can easily judge that the resultant is located in the first quadrant. Okay. Now the third step, that is nothing but finding out the magnitude of the resultant. Okay. So we know that R is the general formula for finding out resultant. R is equal to root of Sfx square plus Sfy square. So substituting the both values here, we get R is equal to root of 17.25 whole square plus 18.24 square. Okay, solving these things we get R is equal to 25.1 kilonewton. That is the magnitude of the resultant. Okay. Now we can find out the angle of resultant, that is Q. Initially it is mentioned as alpha, but here it is mentioned as Q. Okay. So now alpha is equal to tan inverse of sigma SFY divided by sigma SFX. Okay. It is generally termed as sigma V by sigma H. Okay. Now we solve by using the above mentioned values. That is alpha is equal to tan inverse of 18.24 divided by 17.25. We get the value of alpha, that is Q, is equal to 46.59 degrees. Okay. The location of the resultant is given in the diagram. Since both the horizontal and vertical components are positive, it is moving towards the first quadrant. R is moving towards the first quadrant, and the angle of the resultant is 46.59. So hence it is marked as 46.59 in the diagram. This is the location of the resultant. Thank you.